As I said, don't be shy at the end of the presentation to ask questions in English or also in French. I will try my best to understand your French question, and if not, Peter will make a translation for you. So I think I can present you a whole array of different techniques and methodologies applied in our project in Peru. And of course, as you know from this seminar, the number of techniques, methodologies which help archaeology, modern archaeology in investigation is very great, and we were happy to be able to apply many techniques in our project, and I can present now only a selection, and therefore again please ask your questions after my presentation. I think we will have at least half an hour for discussions afterwards, and I can explain many more things to you. First of all, I would like to thank Peter for the invitation, not only for the very delicious lunch, which makes me a little bit sleepy, but I do my best to keep you awake. And I feel very honored to be here in this important series of lectures. We have few opportunities in Europe, I can say, to attend such a selection of good presentation of this topic. And as you may have noted during the previous lectures, this is a very hot topic in archaeology. Every time more we have to deal with these new techniques and methodologies, which are coined with the term archaeometry, and sometimes it's difficult for us archaeologists to overview all these methods in order to apply it in our own projects. So first of all, and this will also be one of the conclusions of my talk, is a modern archaeological project has to be interdisciplinary. We have to work together in groups with other specialists, and we should not commit the fault to believe that we can understand everything. We can proceed to a certain point in our archaeological investigations, but then we have to recognize that from this point on, we have to ask the specialists to contribute with their knowledge. So what you can see here on the slide is just an impression of some of the techniques and methodologies applied in our project work in southern Peru, which for most of you may be a quite exotic region, but you will see this is a very appropriate region for doing archaeological field work, and especially to apply new technologies and to test new technologies to solve very basic research questions. On the left side here in the upper row, you can see magnetometry, a geophysicist at work. Then the second picture is a model helicopter used for photogrammetrical documentation of an archaeological site. Then you have again geophysics, electric resistivity on the field in the plains of the valleys where we are working. Then here we are testing a new dating technique to develop a technique to date stone surfaces, very important in archaeology. And on the right side, isotope studies, our specialist taking samples from a mummy. So as I told you, I will give a short introduction coming from the archaeology and say very few words about archaeological methods. Then I will present briefly the framework of our Nasca Palpa project in Peru, on the south coast of Peru. Hello. And then I will present the special approach of our project, the interdisciplinary approach. And I would like to emphasize that let's say the special character of my talk is not to present one specific technique, as you have seen in other talks and as you will see in different talks like isotope studies or the newest developments of dating techniques, but I am coming from the archaeological side. So my interest is an archaeological problem, and I'm looking for the different methods on the market to apply to my project to resolve the special research questions. So this is a situation in which you will come in the future also. You will hear a lot of presentation on congresses, workshops, and so on of the nice techniques and nice methodologies which can be applied in archaeology, but we have to look for the specific technique which is appropriate for our specific research problem. And when we have selected it, then begins a large process of applying this technique. And there are many, many possibilities where the application of this technique can fail because of the special conditions of our sites. I can just mention one example. When we established contact with this guy on the left, Jörg Fassbender, from the Bavarian State Department of Monuments. He is a specialist in magnetometry, one of the top specialists in the world, and we explained him our problem of investigating a cemetery in Peru, and he said, no problem, I will come, I will walk over the fields and I will detect all the tombs you like. And we booked the flight, he came to Peru, we brought him to the sites, and then we told him, here is the sites, you can begin. And then he told us, oh, there are trees. Here I can't walk. Problem, very practical problem. And this can happen. And this is very important to mention, and also very important for all the strategies to apply these technologies. It is very important, this is another important advice for you. Bring the people to the place where they shall work. They have to look at the conditions to develop the special strategy for investigation. Okay, so I will explain later the interdisciplinary approach of our project, and then I will focus on 3D modeling in archaeology, and especially in Palpa. I have seen in the program there are many good presentations about special aspects of archaeometry, and I saw that some of the aspects are lacking, and I am focusing in my talk on these aspects which are very important for archaeology, which is the documentation aspect. You know, this is one of the technique which everybody has to learn. If you excavate, you have to document, writing texts, descriptions, and you have to make a graphic documentation. This is very time-consuming and an important issue for developing new technologies to solve time during excavations to make a good documentation. So, and then we will proceed to different other archaeometrical techniques, and we will see how much time we have to present the different aspects. So I will present here in 1.5 hours some of our work. We have published about this long-term project basic aspects of several fields of methodology of our interdisciplinary project in a book, which is called New Technologies for Archaeology, Multidisciplinary Investigations in Palpa and Nasca, Peru. This book is available here at the library, and also I am authorized by the editorial to give away PDF files. I will give these files to Peter, and if somebody is interested to make copies, you are free to copy these files for personal use only. Okay? Don't sell it on the market, because the editorial will cut my head. So in this book I am touching the different fields of archaeometry, which are, I think, the most important, which usually are applied in archaeological investigation. We have the field of geoarchaeology. This means landscape and climatic reconstruction. You can see the different disciplines: sedimentology, geomorphology, paleoclimatology, and so on. Then we have the field of geophysics. These are the prospection methods, most importantly magnetometry, electric resistivity, and ground penetrating radar. The last one was not applied by us in our project. Then geomatics. Geomatics is the term which includes several techniques which previously were called terrestrial surveying, geodesy, and which includes now all the techniques of remote sensing, photogrammetry, laser scanning, and so on, and includes also every day more the computer technology, and especially the geographic information systems, which I guess are also already part of the studies of some of you, at least. Then the great field of archaeochronometry, dating in archaeology, basic for reconstruction of every historic process. Radiocarbon dating, obviously. Thermoluminescence dating, another technique developed from the thermoluminescence dating, the optically stimulated luminescence dating, and other dating techniques. And two topics I won't talk about, but which you will find in the book, is bioarchaeology, study of human remains, paleogenetics, isotope studies, and another interesting topic in our research area, archaeometallurgy with material analysis, and also what is called mining archaeology, the study of mining in the past. So just 2 words about the basics of South American archaeology. Of course, we could make a whole seminar about this topic, but I would like to recall one important thing. South America has no written sources. So, as you may know, in the old world, the initial point of many or the most investigations in archaeology are any written source, an inscription or a document or something like that, or we have information from written sources. In South America, we have nothing of that. So archaeology has a special importance because all history has to be reconstructed by archaeology. So what methods do we have in archaeology? Sometimes we think we have so many different possibilities, so many methods in archaeology, but often we are thinking exactly in what I have shown before, all these technologies and methodologies which are not specific of archaeology. What do we have in archaeology? There is the excavation, there is the stratigraphy, which we have derived from geology, so it's a superposition of different layers, as you can see here in a typical profile of excavations, superposition of living layers or architecture, and this helps us to reconstruct the process, the sequence of the social processes in time. And on the other hand, for the reconstruction of history, we have, and I'm thinking just now, I have the German term in mind, the closed context. I'm lacking the word, in French. So this means we have archaeological contexts of different objects which are deposited at the same time. So this gives us the information that these objects, or here the burial and the ceramic vessels, were laid down at the same time. So this is information of contemporaneity. So this information is about the sequence, and this is about contemporaneity. All other inferences in archaeology that we do with archaeological methods are by relations of similarity. If we find this same ceramic style, we assume that it's from the same time. If we find the same burial position, we assume it's of the same time. And for all other inferences, in principle, we need other methodologies and techniques, and therefore it's very important to collaborate with other fields of the science. So this is all about South American archaeology for now. And now I will briefly describe the framework of our archaeological project in Peru. You can see here South America, of course, and you can see already there is a great difference between the green side, the eastern part, the Amazonian region, and here the Pampas of Brazil, Argentina, and you see here on the left side, on the Pacific coast, a light stripe, which of course is due to the desert condition of this site. So in this desert region, which is characteristic for the coast of Peru, is located our research area, especially the town of Palpa, which is 40 kilometers north of the more famous site Nasca. You can see here the yellow part is all completely dry. That's the driest desert in the world, with 5 millimeters of precipitation during the year. And you can see also, according you climb up into the mountains, precipitation is higher, and in the high Andes, up to 5,000–6,000 meters, we have rainy conditions. So in this area, there is the mystery, what we started to investigate, the famous Nazca lines. This was actually the starting point of our project. These drawings here in the desert parts of the coast of Peru are called geoglyphs, ground drawings in the desert, and you can see here the river valleys, the valleys of the river, which come down from the western slope of the Andes and bring the water, flow through the desert, and bring the water into the Pacific Ocean. So, of course, the geoglyphs are an enigma. Despite of many years of investigations and publications, nobody had resolved the mystery of their meaning and their context. And what we can see also on the ground, but not in this picture, are many settlements that border here the valleys, and these settlements were inhabited by the people who made, of course, the geoglyphs. So our our starting point of the investigation was, if we want to know something more about the geoglyphs, about their meaning, their history, and so on, we have to study not only the geoglyphs, but also the settlements, their cultural context, the living conditions, the climate history, and so on. And so we could answer the basic questions, which are: who built the geoglyphs? What did they mean? How old are the geoglyphs? How many people lived there? How long did they live there, etc., etc. These are the typical archaeological questions, which seem to be very basic. What did they eat? Where did they live? And so on, but are sometimes so difficult to answer. So I will not tell a lot about the geoglyphs. I switch directly to the archaeological records that we have in this region, which is very complex and which makes the region so attractive for archaeological investigations. First of all, we have a lot of archaeological settlements of different time periods, which are clearly visible on the ground because we do not have any vegetation cover. No? This is very different from here, for example. If you want to detect archaeological sites, you have to detect them by geophysical techniques or by walking and looking for ceramic remains and so on. This is much easier here in the desert region because many architectural remains are clearly visible on the ground and also visible in aerial photographs or even satellite images. So as you see, we have identified a lot of these archaeological sites, about 700 sites, and from them these are about 450 settlements. Then, of course, we have the geoglyphs, which are sometimes very complex, as you can see in this slide. We have also a lot of petroglyphs, so drawings on the rocks, and you can see clearly by this pictures that these are closely related to the geoglyphs, and at the end this is clear. The history of the geoglyphs began with the older tradition of the petroglyphs. And I regard also as an archaeological feature the geoarchives, the geoarchaeology, because the layering of the ground gives us a lot of information about archaeological processes, about history, of course, mainly landscape and climate history, but at the end, history. So here you see one of the geomorphologists investigating the stratigraphy in a test pit that we archaeologists dug, saw that many things happened in landscape history, and this was the point when we said, oh, this is too difficult to interpret for us, we have to look for a geomorphologist to analyze this sequence. You have seen this before. We have the funerary contexts, a lot of them. We have about hundreds in our research area excavated so far from different time periods, very important archaeological information. And as you all know, also in every excavation you find the objects, the artifacts. In this case, we find ceramics, textiles, because in the desert the conservation of organic material is very good. So we find also bone artifacts, well-preserved seashell, metal, and so on. And last not least, as part of the archaeological record, we have the chronology, and in our case it was very fruitful to reconstruct the whole settlement history in the region during the years we are present there. And on the right side, you I have not to read it all. This is the chronology we developed during the time with our excavation results and the absolute dating results. Okay, we have formulated the research question, and we have seen that the archaeological record is very complex on the one hand, but offers a lot of potential for investigating research questions. And it was a perfect basis to ask for funding for an interdisciplinary research group. And this was established, was financed especially by the German Ministry of Education and Research. There were other funding institutions from Switzerland especially. And this, by the way, is also part of your future work, fundraising with good arguments, because without money you can't do anything. So first is the good idea, then there is a good proposal, and then hopefully there will come money, and with the money you can do good investigation, and then comes more money, and so on. So in this case, the idea was the following. We were interested in chronology, and we looked for specialists who could help us to establish the chronology. So we needed chronometrical methods, C14 dating, of course, radiocarbon dating, AMS, which is a special technique of C14 dating, then thermoluminescence dating, and what I already mentioned briefly before, dating with optically stimulated luminescence. Probably I will explain it later. Then the big problem was, and this was one of our major issues of this project, the problem of mapping large areas. We wanted to make a good documentation of the geoglyphs, despite of 50 or 60 years investigation and publication about this topic of the geoglyphs. Nobody had produced good maps of these geoglyphs. And this is a special issue in Latin American archaeology. I don't know why, but a good documentation, site plans, architectural plans in many excavation archaeological projects are lacking. So this would be a special contribution from our side, and especially I think in Germany, this is a general topic. The first we have to do is a good documentation. Before doing theory, documentation. So in this case, we wanted to map the geoglyphs, and the appropriate technique were the remote sensing techniques, especially photogrammetry and laser scanning. Then we had the problem that we were working in an area where we wanted to detect ancient settlements and ancient archaeological sites. But previously very few people had investigated the region. So for a good survey, we needed, of course, terrestrial survey, just walking around and looking what we can see, but we wanted to see also beneath the ground. So we needed good geophysical prospection methods. I mentioned already magnetometry and electric resistivity. Then, during the years, it turned out, and this is a major issue, and we just talked during lunchtime about this issue, it turned out that landscape and climatic history was a key issue for the understanding and explanation for cultural phenomena, especially of this phenomenon of the geoglyphs. So we looked for people who could help us to resolve these problems, and these people, it's curious because first we looked for geologists, and then we invited a geologist from the United States, and he explained us the formation of the stones and the minerals and so on, and we said, no, that's not what we are looking for. We are looking for the formation processes of the recent history. This is what the geographers and the geomorphologists do. So we invited geomorphologists and specialists in phytolith analysis to reconstruct the climate and landscape history, and also, and I told you that I won't go deeper in this presentation, population history with isotope analysis, which allows us to reconstruct diet of the people who lived there, and also provenance of these people. Where did they live? Where did they live during different periods of their lifespan? And of course, to reconstruct the overall population history. How did people move in these landscapes, or did they stay all the time in one place? We used paleogenetics. Then mining and metalworking, this was a minor issue. And as you can imagine, all these investigations of different groups are generating an enormous amount of data. So what do we do with these data? And this is another major issue actually in archaeological investigation. We are living in digital times, so the data we produce are digital, and if these data become very complex, you have to find a system to integrate all these data to make possible scientific analysis. And for this, the geographic information systems are very appropriate. These are in constant development. You know, geographic information system at the end is a database where you store all your data with a certain structure, and these data are georeferenced. They have a relation to a certain place. So this was very important for our investigation, to have a georeference base where all our informations about the sites, burials, findings, geoglyphs, and so on, and everybody could access these database, looking where are these findings, and do their analysis. So now I would like to begin with the first step, and this will take the major part of the next few minutes, the documentation process. And of course we are doing 2D documentation, but recently with all these digital methodologies, we are able to do 3D modeling in 3 dimensions, which is especially interesting in our research area, which comprises heights from the sea level up to about 5,000 meters. So we can differentiate or structure these techniques or application in landscape modeling, which we are doing with satellite images, photogrammetry, and so on. Terrain modeling, which is typical when we are surveying archaeological sites. It's very important, as I will show, to interpret these sites. Then at the lower level we can model architecture. Of course, this is a reconstruction based on excavation findings. Then we have a lot of big objects that should be modeled, documented, especially these petroglyphs. And we have many small objects which would take a lot of time to document this only by drawing, and just for this region in many cases, for example, complete vessels, decorated vessels, are not completely published because it takes so many time to document it. So let us start with the landscape modeling, in which I include the modeling of the geoglyphs. We have this old, already old technology of photogrammetry. It was developed in the 30s, 40s to create maps from the analysis of aerial photos. The basis of the documentation are these kinds of aerial photos with high precision, made from special airplanes. In this case, in older times, the dimensions were 23 by 23 centimeters, very high resolution. Of course, today everything is done digitally. Then an aeroplane or helicopter or whatsoever flies over the ground, makes overlapping pictures, and according to the human view, stereoscopic view with two eyes, we can measure these images three-dimensionally and create three-dimensional maps. In this case, we have this terrain model. What we need to orient these photos, these images, are control points on the ground, which have to be measured. We do this today with GPS measuring tools. We have to position during 2 or 3 hours this device on the point on the ground, and we can we can achieve very precise measurements up to millimeters for these reference points. So for the whole measurements, we took about 20 points, and then the process afterwards is combining the images and analyzing it to create terrain model and so on. So this is the area where we made the flight to document the geoglyphs of Palpa. This is about 90 square kilometers, and the process of analysis is that first we create an auto photo, so-called auto photos, which is a photo without distortions, a combination of all these photographs. And on this photo, every point appears as if it was photographed directly vertically. So it has the form of a map. You can measure in it, and it's to scale. So this is, let's say, the photographic surface we created. Then you have the terrain model, and finally we need the help of an archaeologist who do an additional work, who interprets the features which we can see in the photographs, and we extract these data, creating so-called vector data. And all this is combined to create a so-called photorealistic digital terrain model, with interpretive features on it. But this is not all. This is static, and we can also create a whole virtual landscape. And this is what we intended to do, because normally, up to this point, we could study the geoglyphs only flying over it with small airplanes, and just in the moment when you saw an interesting feature, it was already gone because the plane had to move. And so we created a huge digital model, and we can move within this model and stop at any point we want. And I just would like to make an example. Yes, it seems to work. So you can see this is a virtual flight through the model. Normally, we process these data on time with very powerful computers, and we can, so at any moment, any part of the model is generated. Okay? I'll just do it again. And the great advantage, of course, is you can stop at any point. And to look at this spiral, for example, or to look on these stratigraphy of the geoglyphs, this would not have been possible in a small aeroplane. No. Just would like to show you another interesting feature. And you see also this is very, very complex. This is only one detail of the whole model. You can see also such details of the production process of the geoglyphs, creating these heaps, gathering together the stones. There are many features we couldn't find out so far what is hidden below it. And we can see such small details. Maybe you can see a face, the mouth, eyes, and hairs going up like this. And this sundials, as it is called today. And of course you see the model ends here, and there you can see that this virtual model. Another example is here. You can see also the animation processes have to be developed constantly. Another large area of geoglyphs with a spiral, for example, here. Again, very interesting features like these heaps of stones, which became very important later during excavations, because these were small stone platforms. And another interesting feature here, these geoglyphs are quite different from the other one, from the large ones. The big ones are from the Nasca culture, and the other ones are from the previous culture, the so-called Paracas culture, which is several hundreds of years earlier. So a very powerful tool, not only for visualizing, not only for playing around, but for scientific analysis. And this was applied here to the geoglyphs, and of course you can imagine, I just returned from Peru, where we documented a huge site, a terraced site from the Paracas culture, about 1.5 kilometers long, 1 kilometer wide, and with these technologies it was we were able to document it in 1 week on site. Of course, now it needs several weeks to analyze the data. Coming back to the research question, I wanted to show you that we selected our methods according to our research questions. We wanted to know what were the geoglyphs made for. So during our investigation processes, we came to excavate on these trapezoids. We found out that beneath these stone heaps were structures, stone structures, little altars, where people in the past deposited offerings in the framework of fertility and water rites and rituals, especially maybe one of you knows about the spondylus shells, which are very important in the Andean context. A symbol for water and fertility was deposited on these small altars. So this was a hypothesis, and we wanted to test it with different methods. And for this were very useful the geographic information systems, which have some tools for testing exactly what we wanted to say. In this case, what we made were a viewshed analysis. We selected one of these platforms we considered very important, assumed the height about 1.50 meters of the eyes of one person of these times, and looked what was visible for this person in the surroundings of his standing point. And the green area are the viewshed, the field of view which this person could see. And you can see there is a very strong coincidence of the fields of view and the placements of the geoglyphs. So this result strongly supports our idea that rituals were performed on the geoglyphs, which should be seen from other parts of the geoglyphs. So we performed another study, which is a visibility study. Here we calculated the general visibility of a point in the terrain. So we have to take in mind that previously people thought that the geoglyphs were images made for the gods to be seen from above. Our theory was that the geoglyphs were stages, places where activities took place which should be seen from other parts on the ground and even from the valley. So this hypothesis is tested in this image. So we can see here the areas in red have a high visibility, can be seen from many different points in the landscape. Meanwhile, the blue fields have less visibility. And now we can plot the geoglyphs upon this map, and we see clearly that geoglyphs are nearly always in places where they could be seen from the ground. So this supports, this is no definite test, but it supports our hypothesis, and this was done with these new digital methods of data management. So another case of landscape modeling helped us very much in the explanation, the reconstruction of climate history, or let's say the visualization of climate history. What the geomorphologists found out was that there was a large process of desertification in the region beginning about 2000 BC, and so these black boxes mean a lot of humidity there available, and then it decreases during Paracas time, and when we come to Nasca times, it reaches a peak, or let's say a lower peak, an inverse peak, So it's very dry in the region, making living conditions nearly impossible. And then humidity rises again, changing very much the landscape in the region. So all these data are visualized in this graphic. You can see the landscape, and the green shading means vegetation. The blue line is for the desert margin, which during time, as you will see, will move up to the east, to the Andes. And you can see at the beginning we have very few sites. It's the initial settlement of the area. Then I've plotted here the early and middle Nasca period, which is the high period of the region, the fluorescent, where the valleys were densely settled and inhabited, despite of becoming drier and drier. But we have to take in mind that there were also the rivers which brought the waters in the region and permitted irrigation agriculture. But in the next period, when it became really dry and obviously the rivers dried out, the desert margin moved up into the Andes, population density dropped down, and at the end, in the so-called middle horizon, population density was very low. The region was nearly abandoned. This was the end of the Nasca culture. This was also the end of geoglyph making, which we can date around 600 AD. So all these complex processes of settlement patterns, climate, landscape, history, desert margin, and so on, can be visualized in one graphics with combining these methods of satellite imagery, which served as a basis for the terrain model, the archaeological data, and the GIS systems. Okay, here again, one side which was crucial for our understanding of the settlement history. You can see we are not anymore in the immediate coast, in the flat landscape of the coast, but we are in the middle reaches of the valleys. This is a site called Parasmarca, where people moved in the last Nasca period. They changed their settlement centers following the water, which became scarcer and scarcer. And our hypothesis was that indeed there was a relation between climate history and settlement history. And our assumption was that the settlement centers were moved literally from the coast to the middle reaches of the valley. So we had to demonstrate or find arguments, archaeological arguments, to support our hypothesis that new settlement centers were founded here. And this was possible here in Parasmarca, and therefore we invested a lot of effort in documentation the surface of the site. You can see here on the lower part of the dry valley, the settlement remains. This was the part which was mapped traditionally with survey instrument, no photogrammetry, no laser scanning, but also with these techniques, of course, you can document perfectly the surface. And we were particularly interested in this area, which is quite different from this irregular structure, the irregular layout from previous settlement remains. And these were remains which were constructed during a very short time period. This is what we could call a colonization. Yeah? So to demonstrate that this was a planned settlement, we documented very well the ground features, and we could see that very regular terraces were built to create this part of the settlement. Meanwhile, in this part of the settlement, we have a very irregular structure. So this is, as I said, one argument to show that people of the Nasca culture abandoned their sites in the lower valleys, moved up and founded new settlement centers in the middle reaches of the valleys. Okay, this terrestrial survey is very time consuming. If we calculate the estimated time for doing the sketch map of the site, to make the survey with the total station, we have to calculate about 2-3 months to make a good plan with traditional methods on this site. We have here another site where we were able to test other technologies and even compare the traditional method with new technology. This is a site of Pinchango Alto, a site of the late intermediate period. This is about 1000 to 1400 AD, and with a quite well preserved architecture, as you can see. This is the typical ceramic from the south coast of Peru of this time period, which allows us to identify the time period. You can see here the wall remains, which are sometimes about 1 meter high. So to document this with traditional methods, you can imagine it's quite time consuming as well. On the left side, you see the map done by terrestrial mapping. Then we, in the process of comparing these methods and developing new methods, we worked with photogrammetrists together who made quite fast this map, which of course in the settlement part is not so exact, but it shows things which wouldn't have been possible to or very difficult to measure for us with normal surveying instrument. The amount of other architectural features in the surroundings, and of course the whole structure of the landscape with don't remember now the word the level lines here to model the terrain. And at a later stage we were able to compare these methods with quite new methods. In this case we combined photogrammetry made with this little helicopter with laser scanning. So the result of photogrammetric image of this one, high precision, you can see every stone. This is perfect for archaeologists. Imagine you have to draw all these stones, you get mad. This is the result of a laser scan, a point cloud, the first result, which has to be processed later to produce a surface map. So I show you a little video of the process of so this model helicopter has here a camera mounted below it. There is a pilot who controls the starts of the helicopter, and then it gets to a point where it enters a predefined flight route where it takes pictures on predefined points. Here you can see still pilot. This all the time controlled from the ground if it really flies to the designated points. So the pilot doesn't have to do anything, it's automatic at this point. And only when it comes down, the pilot takes it over again to manage the landing. So this seems all quite easy. I don't tell you the history about importing a model helicopter to Peru, the problems with customs, the few time which remained to make these flights. So all these are the aspects which are normally not shown by people who offer these technologies. So all these things has to be taken in mind if you plan to do such a application. But in any case, if it works, it's absolutely fabulous, as you can see in this little video, which shows the result of the photogrammetric modeling. So complete overflight of the surface with a quite low resolution. We could make it even higher to see every stone. And you can see also that there are many features which can be important to archaeologists, like these slopes where the ancient people dumped their trash, and which would have been very difficult to measure with a total station. And of course you see the extension of the site, which is very huge and would be very time consuming to document by traditional methods. Of course, this costs a certain amount of money, but the funding institution, according to my experience, are quite easily convinced about saving money or saving time, and by this also money for the documentation of archaeological sites and features. So this model, by the way, was later combined with other models derived from satellite images. So we can merge all these data to create a complete landscape model where the architectural features can be seen within the landscapes. So now we can look at let's say a little lower level of terrain modeling, in this case not done by photogrammetry but by the other technique, the laser scanning, and also here the archaeological task, which is very important in many sites. You may have heard about many different petroglyph sites like Valcamonica, or also here in Peru we have many sites. Documentation of petroglyphs is also always very time consuming, very difficult, and there are developments of every year new methodologies for the documentation of petroglyphs. In this case we have a site called Chichictara, where we have about 400 petroglyphs from Paracas and Nasca times, embedded in a landscape which was studied by us and embedded in a whole cultural surrounding. And we thought that these petroglyph places were places along a trade route from the highlands to the coast, and these were resting points, and this is what we tried to document in this project. You can see here a laser scanner which is producing with laser rays very exact measurements of millions of points in the landscape. Again, like in photogrammetry, we need reference points which are measured with a total station. These points are registered during the laser scan, and then we could generate quite fast terrain model of the landscape where the geoglyphs are located, the petroglyphs are located. So the main scanning positions were here, here, up here, and here, and the petroglyphs are mainly distributed here on the rocky outcrops, and many of them were fallen down here into the valley. So to give you an idea of the importance of this kind of documentation, I just want to show you one example of petroglyphs we found in the highlands. These ones here, you can see here a kind of ape or something like that, and this human figure with these rays on their head. And these petroglyphs were found on the coast. So this means about 3,000 meters above sea level, and this is about 200 meters above sea level, distance about 50 kilometers. So you see the similarity and the obvious relation. Our archaeological method of seeing similarity and assuming the contemporaneity. And here again, this figure, which may be quite similar to the one of the highlands. And this is the route we identified. You can see here the lines which we identified on the ground, and indeed it was a walkway with many different archaeological features, and it was quite clear that this was used to interchange products between the highlands and the coast. And the petroglyph sites of the coast were here, Chichictara, and the highland site with the petroglyphs was up here. So this also a method for visualizing archaeological meanings, documentation of petroglyphs within a landscape. And perhaps somebody of you has dealt a little bit with petroglyphs. The problem in petroglyph study is, at the one hand, the documentation of the geoglyphs, which is in many cases quite difficult. And the other problem is, after documentation, the explanation, the interpretation of the petroglyphs. And most projects end with the documentation because there is no context for explanation of the petroglyphs. So it's quite difficult to excavate on petroglyph site because it's not always clear if the layers, for example, below, in the ground below a petroglyph, have to deal with the petroglyphs themselves. And in this case, it is quite clear that there is a relationship between the location of the petroglyph sites and the overall cultural context, the trade routes, the relation between highland and the coast. And again, these documentation and visualization methods help us to contribute with archaeological data to support our hypothesis. Then briefly, architectural modeling, which is very helpful to visualize our archaeological results from excavation. This is mainly computer technique. Of course, we see here a typical site of the Nasca culture, Los Molinos, heavily looted, but during excavation we found out that many features of the Adobe mud brick architecture was perfectly preserved, and this allowed us to make a digital reconstruction, interpretive reconstruction of this Nasca settlement. This is done today in 3D programs. This is your specialty, I think. This would be here a screenshot of one situation. Of course, the whole model can be turned around, you can walk through, and so on. So this is, these are the possibilities of computer modeling. And another case here, very actual, because this was done, this was an excavation of the largest Nasca tombs so far at the site of La Muña between 2001 and 2003. And then it was covered again. Meanwhile, we published it and made digital reconstructions. And now, in the last year, we got funding for make this site accessible to the public. And actually, we are in a quite problematic project, restoration project, to rediscover it, to restore the Adobe architecture, to cover it, and to make it accessible for the public. And of course, we have to visualize our ideas, how these tombs were originally. We do not reconstruct it in this way, but we put plates and posters where we explain our ideas. And then these posters, we put these reconstruction. You can see here the mummy sitting with together with offerings, probably where there are many more offerings, in the grave chambers, 7 meters deep. This was covered by wooden beams, cane, and mud plaster. And then on the ground was constructed funerary architecture, which was used for offerings and funerary rituals. So again here, based on the excavation results, we visualize our ideas, and this of course is very important for exhibitions, for public work, etc. Now going back to the petroglyphs and modeling and documenting objects, big objects. In this case, we document the petroglyphs themselves, the rocks, again with photogrammetric means. This is the method. We put reference points. Again, we take mainly pictures around the stone, which can be mounted with very interesting new programs which are on the market, not too expensive. Just an array of photographs, and this is processed in the computer, and a 3 model is produced. Again, GPS points are taken to orient correctly and to locate the stones in the space. And this would be a very simple example of modeling made with a small pocket camera. And you can also see that this is not fully processed. What does not appear in the image cannot be modeled, but in any case, it's another kind of documentation of petroglyphs on 3D objects, and you can give the impression of the real location of the petroglyphs. And here you can see beside the flat area there are other features on the side, and you can give an idea of the spatial relations of the object. And of course, this can be further proceeded to smaller objects. A very interesting technique for the documentation of ceramic sherds. You know that also documentation of ceramic sherds is very time consuming. and a colleague first from Vienna and now in Heidelberg developed a method to generate technical drawings of ceramics, profile drawings from laser scans. So the ceramic sherds are put on a turntable, they are scanned, and based on certain principle of geometry we can reconstruct the diameter and the position of the ceramic sherd and produce the desired profile drawing quite fast. And even more interesting, this is for the documentation of whole vessels together with the images which are drawn, the decoration. In this case, one of these beautiful, very complicatedly decorated ceramic sherds of the Nasca culture, very nice but very difficult to document, and therefore we have very few catalogs with a good graphical documentation. In the Maya area we have one specialist, Justin Kerr, who is specialized with one slit camera to document Maya vases which have a certain shape, but only these ones, other shapes do not work. In this case it's different, we can use with every shape, and what is done is simply that the vessel is scanned. You can see here the process, it's scanned, it's turned, and then the full process is automatic, and you get a 3D model with the photographic surface. On this again can be processed to produce rollouts of the images, and of course this is very, very useful for archaeological documentation. You can see here the laser rays going over the object, turning 4 times. So the process of scanning with orientation and everything takes about 3 to 4 minutes. So you can imagine that this is quite fast. The post-processing, of course, will take some time, but in any case it's much faster than hand drawing. Okay, and of course we have some means of 3D modeling which do not have anything to do with sophisticated techniques. This is, for example, a restitution of a model, of a ritual of the Nasca people of the past walking on the geoglyphs. This was done for a television production in Germany. Now we have some time to go briefly over some new developments in other fields of archaeometry. I will begin with magnetometry, which is extremely useful and already a standard in the initial stages of archaeological projects, at least in the Old World or here in Central Europe. This is extremely useful to detect the features below the ground, to plan the excavation, to detect the places where to excavate. We can see here the principle. What is detected with magnetometry is the differences in magnetization of certain minerals in the ground, and the principle is that normally the underground is completely homogeneous because the magnetic minerals during time orient to the magnetic field of the Earth, and if we disturb this situation in any way by digging a hole or putting a wall or putting an adobe brick artificially made, this has a different magnetic orientation, and this is detected by the magnetometer. So the specialist walks with the detector over the ground at a certain speed. The pulses and the reflections are registered in a device which can be seen here, and then images are produced. We used it in different situations, which was not very easy because, and this has to be said in our special South American case, that the magnetic conditions in South America, or in general, the magnetic conditions close to the equator are different than in our latitudes. So this method had to be adapted for the special conditions in South America, and this was the topic of the special research project. But I show you just some results. For example, even on the geoglyphs, the places where the ground was more compacted than the surroundings could be detected by magnetometry, and this helped us very much in the reconstruction of damaged geoglyphs, like in this case, where we can see here many features which are not visible anymore on the ground. We can see them in the magnetogram. And another team developed a new method or a new device for magnetometry, very helpful because it could be pulled with a car, and it reached very high speeds, what means that you can cover huge areas with magnetometry and detect really big settlement areas, for example, in very few time. You can see here the device. You can see the antenna. This is connected with a differential GPS, which records every movement of the device, and automatically all the movements are mapped digitally on the computer. This is just a small video to show how fast they can run over the ground, if there are no trees, of course. But this was applied, for example, recently in Mongolia, where we have large steppe areas, and it was applied very successfully for the detection of ancient settlement, and it produces very fast at the same evening this kind of images. Well, we have an autophoto. They overlaid the magnetogram, which was already georeferenced over the photograph. Here we can see the green part is the magnetogram, where we can see the settlement features. Let me just see how much is this. These are 20 meters. And you can see the features below the ground. These were not very spectacular features, but in any case, we could see that there was a large settlement of the initial Nasca period, and at the same time, it produces a surface model with contour lines. This is the word which I didn't know before, with the contour lines, so you have a perfect plan after ending of the process. Of course, geophysical methods are best when different methods are combined. In this case, on the test field, we combined magnetometry and electric resistivity. Here again, Mr. Fassbinder with the magnetometer, and walking on this field, you see the geological features below. Here, and in ancient times, the river had its bed, and we see perfectly the structures, but we see also very, very slight features here, which seem to be regular and seem to be settlement features. The big advantage of magnetometry is that you can cover huge areas in quite short time. With other geophysical prospection method, you can work rather in smaller areas, like in this case of electric resistivity, which means that you put nails in the ground, connected with a cable, and put electric shocks, let's say, in the ground. They penetrate the ground to a certain deepness according to the resistivity, and different materials have different resistivity, and from the reflex of these signals you can calculate the structure of the subsurface. This is recorded again in the computer here and visualized in this case. You remember there were these features visible in magnetometry, reproduced also in the geoelectric resistivity image, and you can see also that of course the area covered by the electric resistivity is smaller, but we can focus on certain areas of interest, and also the data of electric resistivity can be visualized also in 3D. In this case, this is an example where we reduce every time more the features to the features of our interest, and this would be the area where we should excavate. This was not a very spectacular finding, but interesting in any case. What you can see are the pits where ancient people took the earth out, the mud, for the production of mud bricks. So it's a mud pit, let's say, for the construction. And what did this mean? In our context, it was quite important, because just 50 meters to the south we excavated a large undisturbed Paracas settlement, and we did tests about the material of the adobe bricks, and indeed we could demonstrate that this material proceeded from these pits we had detected with geophysic methods. So again, these methodologies are very helpful in our archaeological investigation. Then another important field of development, of course, is physical dating. Radiocarbon dating is known to everybody of you, I guess. But this also is in constant development. It's still expensive, although not so expensive anymore like 20 years ago, due to the new developments. We can see here, for example, an installation and device for the parallel processing, the preparation of radiocarbon samples before the dating process. And the idea is simply that normally these dating machines are very expensive, and normally it is very useful if they are working all the time, but because the preparation of the sample is also very time consuming, the big machines only work from time to time, and when enough samples are available, then dating is done. So the idea is to decentralize the preparation, sample preparation process, and the proper dating process in different laboratories, and this would be a machine for the automatic preparation of samples. This is an image of, let's say, an old AMS, accelerator mass spectrography dating facility in Zurich, and another one here at Purdue University in the United States. You can see the dimensions. You can imagine the costs of these machines. This is only the accelerator, and there is a huge array of other machines for the processing of the samples. And these machines have been reduced enormously in size recently, and we participated in this process of the development of this machine. Now it fits into one laboratory. This is Bernd Kromer von Heidelberg, one of the specialists in radiocarbon dating, proud of his machine, which is able to process AMS samples at a quite low price now, about 150 euros. We remember some, let's say 15 years ago, we had to pay about 1,200, 1,500 euros. No, these were marks, German marks, for one sample. So there is a lot of development also in this field, and last not least, I will briefly explain another fascinating technique which was applied also in our project and developed during the application, which is the OSL dating, optically stimulated luminescence dating of stone surfaces. Let me just see which slide I have. No, it's already the end. Okay, the idea is that maybe you have heard about thermoluminescence dating. Thermoluminescence dating is a dating technique for minerals which are heated, especially ceramics. So the idea is every mineral product has a certain mineral structure, a regular structure in the best case, which is constantly disturbed by natural radioactive radiation. So there are the electrons in the crystal structures, and by the radiation, some of the electrons are pulled out of their original position. So there is a damage in the crystal structure. So this process of damages is very regular. You can count it, and there is a direct relation between the amount of the damages in the crystal structure and time. So you can count from the damages in the crystal structures to the time elapsed to a certain moment. And the certain moment is the one moment when the crystal structure was complete. Now, the important aspect is that if you heat a mineral, then all these damages are reversed. Heating is putting in energy, then the electrons jump back into their original position, and all the damages are healed. This is the important factor during the measuring process. So that means if somebody takes clay, forms a vessel, and heats it in an oven, the heating process heals all the damages. And then it is exposed again to radiation, and the damages accumulate. And from the count of the damages, you can count the time elapsed from the heating process. So this is thermoluminescence, working with heat as a form of energy. Also, at a lower level, sunlight is another kind of energy which affects mineral surfaces. And this can be used for an analog process to detect the ages of surfaces which normally are covered and at some moment are hit by sunlight. The hitting of the sunlight means the healing of the damage processes, and if it's covered again by, let's say, another sediment, then the accumulation of damages take place, and we can calculate from the amount of damages the moment when the sediment was covered. And as this works with luminescence, with light instead of heat, thermoluminescence, this process, this technique is called optically stimulated luminescence dating. So this is applied in many fields of geomorphology to date, as I said, sediments, and in this case it was further developed to date stone surfaces. In this case, quartz and feldspat are the minerals which are most useful for the dating, and here in the case of the geoglyphs it was a special case for a dating application, because the geoglyphs are made by moving away stones to another location. The clearing of these areas is done by moving away the dark stones from the surfaces. So this process means a surface which was excluded from light is lighted for a moment. This means all the damages are healed. It is deposited again, and the damages in the stone surface accumulate, and we can, in the best case, date the moment when somebody took the stone and put it on another place. This worked quite well. This is still in process. We reached an exactitude about 200 years plus minus. This is not very good for archaeology, but on the way to good methodologies, quite good results. These are some images of the taking of samples, which has to be done by night, of course, because if we lighten the sample, everything is gone. So we take the samples by night. We marked the places on the geoglyphs during daytime, went up on night, drilled small samples of stone surfaces from the stones, brought it to the laboratory, and with the special device we could test directly the quartz and feldspat surfaces we were interested in. So this is, let's say, a good overview, I think, of what can be done with new developments in technology, in archaeology. Of course, there are many, many more things which are developed, and this is a field which is constantly developing, and it's very useful to attend meetings where new technologies are presented, just to get an idea what is possible in archaeology or for specific research problems. And I think you have seen a little bit what is possible in one project with these new technologies to resolve very specific research questions. As I said, it is important first to work in a team, to keep contact with specialists, and in the best case, bring them to the place where they should work, to see the situation and to adapt their strategy to what is really desired. So I think if you have questions.